let us discuss about the total internal reflection by the wavefront. Okay, now total internal reflection. Total internal reflection by wavefront. In terms of wavefront. Under ray optics, we already studied total internal reflection. Now we are going to represent the same phenomenon by wavefront, in terms of wavefront. As we know, we have got two different media. So this is the line of separation between two media. Let me represent this by a denser medium. This is the denser medium, and here you have rarer medium. Okay? Right. Let me consider this as the normal. When I am light, in terms of wavefront, let it go like this. This is the incident ray, and this is the incident wavefront. So let me say this is AB, right? So AB is the incident wavefront. AB is the incident wavefront. And similarly, of course, XY is the line of separation between two different media. Now the light travels from denser to rarer. This is the first one. Now, as you know, it gets deflected away from the, so this is the normal, N dash is normal. N dash is a normal, which is nothing but the perpendicular line to the plane of refraction. So normal, this is 90 degree. So here the refracted ray will get deviated from the normal. So actually it should have gone like this. Instead it gets deviated. Okay, that is away from the normal, away from the normal. So here this is the angle of incidence, and this one is angle of refraction. And if it is I, we already discussed, this is also I. Okay, and what about this? This will be parallel, and they get refracted like this. So by the time A reaches D, that is the first refracted ray, and this is C, and we can call it this as CD, right? So this is the secondary wavelet started from the refraction point. So we can call it CD is refracted wavefront. Refracted wavefront. And what about I? I, we already know the angle of incidence. Angle of incidence. What about R? Angle of refraction. Angle of refraction. CD, as I already discussed, that is the refracted wavefront. Incident wavefront AB. So I hope everything is clear here. You know very well, this is perpendicular, so this is 90 degree. Okay, and if it is that is R, and this is also R. This angle is R, right? Okay. So I hope everything is clear. So this is denser medium, this is rarer medium. Right? Okay. Now let me do the same with the increased angle of incidence. So the angle of incidence, when it increases, what happens? It gets further deviated down and reaches 90 degree. So actually, let me use the color one so that you can understand better. Now is that? So this is angle of incidence, this is angle of incidence. Now I am increasing this. Okay, so let me draw like this. Now what happens? It gets further deviated downward. Okay, now the angle of refraction will be, that is almost passing through the plane of refraction. So let me draw like this. Is it clear? Now what is the angle of incidence? The angle of incidence is increased, and for which the refraction is 90 degree. Are you able to follow? So R here is 90 degree. 90 degree. Okay. So otherwise, let me draw separately also. Okay. Okay, so let me use different colors so that you will be able to understand. So this is 90 degree. So this is R is equal to 90 degree. And this is the critical angle, is it not? So that is I. C, you can put C here. So this angle is C. Are you able to understand? So this is C and this is R is equal to 90 degree. So when the angle of, when the angle of refraction is 90 degree, what do you mean by that? When the refracted ray just touches the surface, that is grazes the what? The line of separation of the medium or refracting surface, and that is 90 degree. Therefore, the respective I is called critical angle. Now let me use another color. Here, let it further increase. When the angle of incidence increases further like this, I think I have used yellow color. So are you able to distinguish? Otherwise, let me use blue color. Blue or red. Blue. That will be ideal. Okay. Are you able to see this? So now the angle of incidence further has increased. So it means the I has crossed C. In that case, the total internal reflection takes place in this way. Are you able to follow? So here you have to take the first, that is secondary wavelet, as an arc, and this will be the D dash you can put. This is the D. Clear? Okay. Please go through this diagram carefully. Let me focus. Okay. Otherwise, you can draw in this way also. That is, you can have a straight XY and put normal like this. You can show separately also, and this will be a better diagram. Here, we draw the incident light in this way. And what about the wavefront? It goes like this and hits at A and C. Now it gets deviated like this, and you have to consider the secondary wavelet, okay, and that can be the 90 degrees, so the tangent is 90. So this is D. So this is the refraction where I is less than C, you understand? And here, and this is the angle of incidence I, this is angle of refraction, okay, and if it is I and this is also I, that is you can draw the incident wavefront 90 degree, incident wavefront 90 degree, okay. So this can be B. So AB is the incident wavefront and CD is the refracted wavefront. Angle of incidence, angle of refraction. This is denser medium. This is rarer medium. Okay, refractive index of denser medium, refractive index of rarer medium. Denser, rarer. Denser medium or rarer medium. So same diagram can be drawn with. Now let me increase the I, and I hope you should be able to understand the deviation will take place in this way. Note down this arrow mark, or able to see the arrow mark. So in this way. Now the I increases. Okay. So when the I increases means it increases like this, away from that. Further increases. So this is I. It has increased further. So that is equal to critical angle. So it grazes the surface. Okay, the refracted ray grazes the surface. In that case, R is equal to 90 degree. When R is equal to 90 degree, the incident angle is called critical angle because it just touches the surface of separation between the two media. Okay, two media, right? And this is the wavefront, incident wavefront. Let me draw the incident wavefront, and this is the incident wavefront. AB is the incident wavefront, and here it has gone like this. So in that case, the refraction will be this way. Or it will follow, right? Now, this is the critical angle. So at R is equal to 90, what is the incident angle? That is called critical angle. Now, let me take the third one. So here I is equal to C, and here I is greater than C. So when I is greater than C, what happens? That is, it gets totally internally reflected. Now I am increasing the I further. Okay, so it goes like this. So I have increased. So this is the angle of incidence. And what about incident wavefront? It will be like this. Okay, so this is the incident wavefront A, B. Now, as I already told you, it gets further deviated and exceeds the critical angle, is it not? So, greater than 90 degree means it is totally internally reflected. It goes like this. Okay? Totally internally reflected. And what about this angle? This is R. And what about this? This one is I. Okay. So what is the condition for total internal reflection? I should exceed the critical angle. I hope everything is clear. Okay. Right. This is a very important diagram. Are you able to see? See here, denser medium 2, denser medium 1. So from denser medium to rarer medium, when the light goes, it gets deviated. So actually you should have gone straight, but it has slightly deviated. Okay. And here, when it further increases, it touches the 90 degree. So at that point, I is equal to C. And here it further increases, that is exceeding C, so that internal reflection, total internal reflection occurs. So you can show a little bit a deviated line also. Okay. 1 minute. See, this is undeviated line. It has further deviated like this. So you can show like this. Okay. So this is T and R is this. I think now the diagram is very clear. Right? So it is shifting in this way, in this direction. Pointed towards, that is pointed away from the normal, N dash. Okay. Got it? Now, let me say there is sin I by sin R. Sin I by sin R. What is sin I here? That is BC divided by AC. Is it not? Considering triangle ABC. So what is I? You know, this is I. This is R. I, R. So sin A means BC by opposite by hypotenuse. So BC by AC. And then what about sin R? That is, you can take this one. So this is also R. So this one will be R. So adjacent side divided by hypotenuse. Is it not? So here AD. Okay, AD divided by, sin R, opposite is AB. So AB by AC divided by AB by AC. Therefore, sin A by sin R is equal to BC by AB and AC can be cancelled. So what is BC? BC, the displacement of the incident wavefront. And what about AB? That is this one. This is BC and this is AB. Okay. So, and here, remember this BC. Okay. This BC is equal to, this is in the medium 2. Okay. So, BC is equal to, we know already, displacement is equal to velocity into time. In this case, BC is the displacement, is it not? BC is the displacement, that is equal to velocity. So this is the medium. So velocity of light in the medium, denser medium. Okay, let me say this is denser medium. Put M, this is rarer medium. Let it be A. Yeah. So Cm, the velocity of light in denser medium, into time t. Is it not? T. Okay, right. And what about AD? This is AD. What about AD? That is AD. So AD is, and here we got already this R is here, not here, R. This one is R alternatively, okay, R. So this one is in the air medium. So the same equation can be applied. So AD is equal to, and it should be not AD, because AD, you can have this one and R is here, okay. So AD into T. So AD is equal to C air, that is velocity of light, because this is a rarer medium, so air, velocity of light in air into time, you can put T. Therefore, you can replace this BC by this one CMT divided by CAT. T can be cancelled. Therefore, it is the ratio between velocities of light in medium and air. Okay? And sin I by sin R is nothing but mu. Mu of what? Second medium with respect to the first medium. So that is the convention, or you can simply put the refractive index also. Okay? Please note down. Finished? Shall I erase it? Right. Let me continue with the three cases of AD and AC. Okay? Now listen. AD and AC. So you please talk at this equation or this equation. These two equations. What is sin I by sin R? And here let me talk about AD and AC. AD and AC. Okay. So in the first case, AD is less than case 1. There are three cases. Take down. Three cases. One is AD is less than AC. What is AD here? That is this one, refracted ray, and that is the arc length of the secondary wavelength of the refracted ray starting from A. Got it? So that is AD. That is less than AC, or you will follow. So AD is less than AC. This is first case. The second case can be these two are equal. It means what? Just they graces the surface as in this case. So here AD just matches with C. Is it not? It should have gone like this. Now it matches. So you can call it D as well as C. And that is why AD is equal to AC. It means at critical angle. So second case is AD is equal to AC. Third one, AD is greater than AC, where it exceeds 90 degree. It means the total internal reflection takes place. So this is AD, and here you have the D here. So AD is greater than AC. Okay, so this is C, AC. Right? Now, so in the first case, when Sin R, listen carefully. In this case, what is sin R? Sin R is nothing but, that is AD by AC. So AD by AC. So in this case, AD is less than AC, and therefore, what about angle of refraction? It can be less than 90 degree. Are you able to follow? Okay. In the second case, sin R, it means that is AD is equal to AC. So AD is equal to AC means both of them are AC. It means it is 1. We know very well, when sin R is equal to 1, R is equal to sin inverse of 1. It means R should be 90 degree. So this is the critical angle. At that time I becomes C. In this case I is less than C. Is it not? Right. And third, sin R is equal to, in this case, AD is greater than AC. So therefore it increases C. Is it not? That is R is exceeding 90 degree. Are you able to follow? At that time, that is total internal reflection occurs. It means I becomes greater than C. So total internal reflection occurs. So now we need to study the conditions for what? The total internal reflection based on this. Okay? Please do this. Right. Now what is a very important condition? That is the light should travel condition for total internal reflection. Condition for total internal reflection. Point number 1. That is the light should travel from denser to rarer medium. Okay? Denser to rarer medium. Second, the angle of incidence. The angle of incidence should be greater than the critical angle. So these two conditions are very important. Okay? For exhibition of total internal reflection. Is it clear? It is almost similar to the ray optics where we have studied the total internal reflection. Now we are interpreting in terms of wavefront. That makes the difference. Right?